Hello, I'm Max Orton, a student in Dr. Chapman's EGR 150 Intro to Engineering course at CFCC, and this video is about understanding the mechanics of a universal joint. A UV joint is used to transfer mechanical power between an input and an output, but more specifically when they are both at an angle to one another. The most common use of a universal joint is on the driveshaft of vehicles, which transfers power through the drivetrain while still allowing free movement of those components. The most common materials used in UV joints are either aluminium or steel, and the material choice of the joint usually corresponds to what material the engineer designed the connecting shaft to use due to the two parts needing to be welded together for assembly. A UV joint has three fundamental parts. Two usually identical yokes which are offset 90 degrees from one another and a cross in the middle which is on bearings that connects the two yokes together. When rotational energy is applied to one joint and both yokes are perfectly in line, they will rotate at the same speed. But an interesting aspect of the joint is that if both axes are at an angle, they will have to rotate across different planes. So if the input is rotating at a constant speed, the output will vary in its velocity due to the cross in the middle rotating back and forth slightly throughout its motion. The graph on the screen represents this phenomenon and shows the output's fluctuating velocity relative to the input. Obviously, a universal joint would be unfit for use in most machines if the output just sped up and down randomly throughout its rotation. So to solve this, a second universal joint is used which essentially cancels out the fluctuating velocity. A constant velocity input will be transferred into a fluctuating output, then that fluctuating input will be transferred back into a constant velocity output. And that's the basic concept of a UV joint's functionality and usage.